This is a production of Cornell University.
We're going to take a step back now. We're going to move away from the soil forming factors, and we're actually going to start talking about the processes that produce this change. Okay? The factors are the conditions from which the soils form. The processes are the things that act on those conditions to produce the soils. No yawning. Okay. Is that a hand? No? Oh, just stretch. Okay, soil forming processes versus factors. There are 4 processes: addition, losses, translocations, and transformations. And we're going to go through all 4 of these. Okay? Additions. Here's the whole slide. You've seen this slide before, but here's this slide that sort of shows the direction of flow. Okay? Additions, they can come in from above, they can come in from below, they can come in from the side. Certainly imagine organic matter coming in from above, but you also can have water coming in from above. You also can have water coming in from below, or it could literally be coming in downslope. You know, this is an upslope position and it's moving into the soil. Losses are basically the same thing. I could have erosion basically stripping stuff off, but I also could have leaching. And I can have leaching going straight down, but it also could be going downslope. I'm also going to have translocations. Things are going to move through the soil. Okay? Organic matter moving down through earthworms. Clay stuff moving down through alluviation, being entrained in water. Okay? I also can have transformation, where something stays at that one location and is transformed into something else. The easiest one of that to think of is organic matter. Okay? Organic matter decomposes. It's no longer a leaf. It now becomes biomass, and that biomass dies. Or it becomes a leaf, it gets eaten, and it gets cast. Okay? Those are transformations. You can also have mineral transformations. And you guys have heard me start talking about secondary minerals when we were talking about parent materials. Mineral transformation is literally mineral 1 gets changed into another mineral through chemical weathering into mineral 2. Still in the same location. Okay? Seems pretty straightforward? Let's start with additions. Okay, additions, the dramatic additions that we usually talk about are organic matter, deposition of plant material, but we also have solutes, so salts moving through a system. Certainly think of out west where we're looking at groundwater bringing salts into a system. Okay? We also can have sediment, whether it's water deposited or aerial deposit. Okay? Wind deposition, that's what those lusses were on top of the arc ports. Okay? Wind is moving things in. Okay? I have a whole list of stuff here, and that's on your slide and on your PDFs, but we're basically a lot of different type of examples. Okay? Good addition that usually people don't think about is gas. Gas coming into the system, CO2 or oxygen, okay, as well as all the other gases, nitrates and things like that, that potentially can be coming in either as dissolved in water, but also as a gas. Okay? Some good examples. Yesterday we started talking, we've been talking about lust with everybody out in the field, and I threw these slides in here, I guess last year, because there was sort of this question, well, actually, how much material is actually being moved? Okay, and the question came up again yesterday, one of the days. I mean, really, how much material are we talking about? Okay, this is pictures from the Dust Bowl. This is archival stuff from the Library of Congress. But here you can see these cars down here, and this is a big, huge dust cloud. Okay, here's the truck basically taking off, you know, and driving down the road, and you can see this big, huge dust cloud. Here is the deposition of that material. Okay, that's a house, basically buried under the loess. Now, this was an anthropogenic source material. This stuff was due to human activity. Now, imagine how much larger scale of an event we're talking about when the glacier's doing this. The glacier's moving through. It's basically creating all of this mixed material, and then it's leaving. Vegetation hasn't had a chance to stabilize any of this stuff, and I have this cold ice cube up there, and I've got this hot body of land down there. You're going to create a lot of convection currents. And these convection currents are going to selectively pick up this stuff, and it's going to deposit it. That's why you have 50 meters of stuff in parts of China and in the Midwest. Around here, you have smaller depositions, but it's everywhere. Now, granted, it has been reworked since vegetation and humans have moved into the system, but that's where that loess comes from. Does that make sense? Now, go. Loess is a wind silt deposit. Okay? Now, this I'm portraying, this is as an addition, but it's very easily could be portrayed as a loss as well. Here are some more additions. Here's a road that's basically been buried. Now, this is an addition not through wind, but this is a water addition. Okay? Here's another, you can't actually see can you guys actually see the writing? This is an A horizon, this is a B horizon, this is a buried A horizon, and there's a question mark on whether this is a B horizon. So what are we looking at here? A mudslide. This actually happens to be a water deposition event, but this was a soil, and then it got buried by material, and a new soil formed on top of it. That's a rather dramatic addition, but they are all pretty dramatic. Now, the pictures I showed you, the reality is that most of it's coming in very small dribs and drabs, but it is an addition. This is just an extreme example. Here's another example. I don't know if you really can pick this one out, but actually I don't even know where I got this slide. But there's a soil horizon here that's basically an A, and then you got deposit of stuff, and then you've got this huge, this is all loess that's been basically deposited on top. So that, just to give you another example of how deep these soils are formed on this loess. This is the Midwest. Okay, the rounded stuff down here, this is obviously sort of water distributed material, if it's rounded rocks. Okay, I got a soil that formed on top of it. I got a little bit more rounded rocks, and then basically starting right here, up, it's all loess. Here's another addition event. Here's an A horizon. The B signifies that it's buried. Okay, an A horizon was formed down here. And then I got a C, and then an AP at the very top, the AP, that plow layer. See all this strata? Flood after flood after flood after flood. Okay, remember the arc ports that you saw? This is the type of stratification that we're seeing. Fine, coarse sands, all strata based upon how strong the flood event was. Go.
So it still counts as a C, even though it was like put there in strata? Like I thought the C was like untouched.
The C is untouched by soil genesis. Okay. Remember when we talked about the parent material? I don't have that slide in this section, but the parent material can be transported, and there's a variety of different ways of transport. The transport in this case happens to be alluvial, alluvial water. Does that make sense? All right, so we have additions. We can have losses. And this slide is basically the same slide as I showed you before with a change of losses at the top. Because anything that brings something as an addition can also take something away as a loss. All right, so we have the sediment lost by erosion. We have solutes leaching to groundwater. We have organic matter basically lost to oxidation, decomposition rates. Okay, and then the whole slew of little examples that I won't go through. But I could every slide that I just showed you, I could basically use as a loss slide. Because all that material came from someplace else. Okay? Most dramatic is this slide right here, but basically we're looking at a gully. The soil is basically up at the top there, going all the way down into the sea material. All this red material is weathered material, and these guys are basically mining it. They're backing the truck up into the gully, helping the gully along, But that's a loss. Erosion events here, basically taking the field away. You can see these sinks. The sinks and then slides, sinks and slides, sinks and slides. Some of these can be rather dramatic, where we have sort of flood events. I'll stop there. So questions on that one? Does that make sense? Anything that you can have as an addition, you can have as a loss. Wind, water, gas, worms, it all happens. Okay? All right. We're good with additions and losses? Let's start moving to translocations. Okay, translocation is a material moving from one part of the soil to another part of the soil. This is not coming from another soil. It's coming from within the soil. On top of the soil, moving downward, the bottom of the soil moving upward or side to side. Okay? The classic one that we give examples of are these salts. This is why I gave the example of the Mann Library Tunnel. You go over there, you see salts, the water moves into the system, the salts get dissolved in the water, and then the salts move with the water, and then when the water evaporates, the salts are left behind. The salts aren't changed, they're dissolved, but they're still the same salts as they started with where they get there. Okay? So certainly in the humid environments, all the salts, because we have enough delivery of water, the salts are basically going to be washed out of the soil system. But as the system gets drier, that water comes in, it doesn't necessarily make it to the groundwater, it potentially comes back up. Okay? And at this point, if you have evapotranspiration, plants are going to start sucking up this stuff as well. The salts are going to start accumulating. Now in really dry environments, those salts, the water comes in, it dissolves the salts that are in here. The water comes down and then basically turns around. It's not going to make it to the groundwater because of evaporation and capillary action. The water is going to come right back to the surface and be gone. I mean, it's going to evaporate, and the salts are going to be left behind. The drier the system, the higher the salts are going to be. In fact, they're going to come right to the surface. Now, added into this fact, with the salts, also think about additions. I have a landscape that's bowl-shaped. Okay? Rains everywhere. I've got salts everywhere. But over the years, those salts are going to start accumulating down at the bottom of my bowl. Because it's going to be raining, the rain is going to dissolve the salts and it's slowly going to move it farther and farther and farther down. Think of Salt Lake City. Think of the Great Salt Lake. Okay. Here's some examples. These are the extreme examples of salt, basically salt formation. This is basically the salt pans. You can see it's dramatic. The salt's all the way up to the surface. Okay? But these salts can actually accumulate around here as well when we over-fertilize or we over-salt. Look at the sidewalks in the springtime. Okay? All along Cornell. Now, Cornell sprays the salt so that people don't slip and sue them. Okay? But that salt is going to move someplace. Now, you guys, when you go up and down Tower Road, you notice how the sidewalks, there's the grass on either side of the sidewalk kind of like not there. Okay? Now, there's two reasons why that grass is really not there. One is that we walk on it, but two is there's a lot of salts that are coming off from the salting of the sidewalks. That salt gets into the soil, and it makes it very hard for the plants to come back. Okay? But that's what's going on here. Okay? This is still a salt accumulation at the surface, but we're starting to see salts like this around here because of over-fertilization and salting. Here's another translocation. Now, I focus mostly on the salts here, but you can certainly imagine that other things will translocate. You guys saw them this week. What horizon is a horizon of translocation? The BT horizon, right? Clays came from the top. They weathered from up there, so that was a transformation as well. But they turned into clays up here, and then the clays got entrained in the water and moved farther down and got put into those BT horizons, right? Okay, well, here's a really cool slide that sort of shows you that. What we're looking at is a sand grain right here under polarized light. Okay, so the light is basically shining one direction. Okay, and you're see all these sort of lines here? That's the clay coating the sand grain. Okay, the clay, you can tell that this is translocation because the clay, to have coated this like this, has to have moved into that location and made a sort of paint job over it. Okay, here's another sort of slide of the same thing. This is a larger scale, so these are the same sort of sand grains as you're seeing up there. Okay, but you can see the oriented minerals in there. Those oriented minerals are the clays. this is what those BTs were like. If we had taken some samples of those BTs, the sand was still there. I mean, when you guys textured those, you felt the sand, right? Okay, the sand is not disappearing when the clay is moving in. The clay is just filling in all those cracks. And we have that accumulation of clay. Now remember my story about how those BTs, if I did a stop action photography, it would look like they're moving up. Okay, imagine here's that horizon. Okay, the clays are coming down and clogging sand that's up here, but ultimately the water is going to work its way down through here, and these clays that are at the bottom are going to be weathered away. Okay, but they're always going to be oriented, and that's what we're seeing. Great example of translocation, and actually a rather pretty one. Okay, questions about this one? Then let's start talking about transformations. Okay, transformations, predominantly we're talking about clay formation, but we also going to be talking about organic matter. And the example I have to show you is an organic matter one. But we're looking at mineral alteration in place. I have a rock. Okay, it's a very small one, so it's a clay-sized rock, but I have a rock. Okay, to that rock, I add water, and I change the temperature, and I put some organic acids in there. What's going to happen to that rock? It's going to start dissolving, right? I mean, that's that weak acid in a million years sort of story. Okay, if it's dissolving, the rock is still there. Some of it's leaving, but it's being transformed because the rock is being dissolved selectively. Certain things are going to be dissolved first, which means that rock is changing, and it's changing in place. Okay, now it happens to be a clay particle, a clay mineral. It basically changes from one mineral to another. Mineral alteration in place, translocation, or transformation. Make sense? Yeah? We also can have scenarios, and this is what you're going to see in 2 weeks. We can also have a translocation event that then turns into a transformation event. Okay, I've got that rock, remember? Okay, it's a clay particle. I start dissolving it, and things leave it, right? Well, where do all those things that leave it go? Some of the times they're lost from the system. They basically wash out. But sometimes they're just translocated farther down into the system, where they can reform into something else. Okay, so that's a translocation and then a transformation. Does that make sense? Okay, you will see these when we start talking. You won't see them, but you'll be able to see the scenario when we start talking about the Fragipan in 2 weeks when we go up to the Martin, up on the top of Mount Pleasant. Okay, these materials are extremely dense materials. And there's a couple of theories as to how these dense materials arrived. One of these theories is that I have stuff up here that's weathering. It's being solubilized and put into water. Then it's moving down into dense zones. The dense zones stall the water, giving the opportunity for all the stuff that's dissolved in that water to reform into a crystal, making that dense zone even denser. And when we get up there, you're going to see this stuff is really hard to dig through. You're going to be taking a shovel and you're going to be wailing on it. It's that dense. Okay? Do we feel comfortable with this? Questions? No? All right. The one example that I have here is organic matter. This is a Japanese, basically looking at different temperatures. But they start as a fresh material, and as the temperature changes, you can see the transformation. Okay? All right. Congratulations. It's Friday. Guys, have a great weekend. Finish off the day well, and I will see you Monday.
This has been a production of Cornell University, on the web at cornell.edu.